finished my bachelor's in supply chain first in business. Then I worked for a couple of years in the Bay Area in the semiconductor industry, as a matter of fact. And then I decided I needed to come out here in Portland because I wanted to experience how to do research and not just have it driven by my thought, by my own tangent. I needed to hear other people's perspective. I needed to hear other thoughts, and I needed it to be in a more systematic fashion. So so what if I want to help people, but how do I go about doing that? To make it into reality, I needed to get the right resources and to have that accessible and not just be a wishful, not just be wishful thinking.
Right, yeah.
So to be able to think in a scientific manner and to break down problems and to problem solve, to have a goal and find out different methods to reach it scientifically and be able to repeat it, not just do it once and be like, okay.
This is it.
That I don't have a lot of experience in. So I would like to, I am ready for it, and I would like to really learn. And that's why even like this was my first proposal writing. Even though I've been in all these different programs, even then this is my first proposal writing, and I'm very excited about it because for a PhD student in grad school or later on in life, you need to be able to sell what you're doing. You need to be able to tell a layperson what you're doing, why you need money for it, and they better be interested in it. And to take all these complex terms and then simplify it, and then build it up again to be this enormous, to be of enormous benefit and potential for the human race. I don't know. It's a skill set. It's awesome that I'm able to do this now rather than when I actually need the money.
Right.
Because that would be so nerve-wracking. So I don't know. I love it.
Yeah, nice.
I am very lucky. My advisor is very awesome. She's given me so many opportunities just to how to evaluate a journal, whether that is a suitable journal for publication or not. It's just simple things like that that you wouldn't necessarily learn, and unless you're in that situation, later on and you're forced into it. All this is like, okay, what do you think about this? Well, have you thought about thinking, it in this direction or stuff like that? I'm hoping that this program opens up more avenues of thought for me, and I'm hoping that there are more structured items like this proposal writing, or like doing like a presentation or how to do a poster, stuff like that. I would love to learn. And I prove to myself that I'm able to be an independent thinker, and I want to go into a PhD program knowing what I want to do, and I want to do it fast. Our current research has to do with exciting T cells for making them have a faster, stronger response towards cancer cells. And to do that, we are artificially exciting them by or you could say externally stimulating them by making these nanowires, which are coated with alumina, and it is biocompatible, first of all, and secondly, it does what we are asking it to do. And so currently we're quantifying this, and not just saying yes it did once, but we're doing repeated experiments on the same thing, and also quantifying it statistically. And we were getting some very interesting results, and so we thought that we would be in time to submit a paper for a particular conference. So we were working towards doing some repeatable studies and doing some very cool but interesting stuff, but unfortunately, despite our best efforts, we didn't have everything under control. So unfortunately we couldn't submit the paper, but it was an incredibly, I don't think I have worked as much and learned as much in such a short period of time. And how did I go about learning it? With lots and lots of help. I'm not afraid of asking for help, which is a good thing. not shy about admitting that I don't know anything. So, I thought I understood what the nanowires were. I thought I understood it by simply looking at the previous published literature and results, and I thought I had a good idea about what that meant. But looking at it and trying to manipulate these microscopic techniques to figure out, okay, what does it physically look like is a totally different experience. For example, doing a TEM and seeing the nanowires in depth, their height, their width, how they actually look like in the TEM is a different aspect from actually preparing the sample for the TEM imaging. And because that actually requires you to scrape off some of the nanowires and put it onto something, and that was when I was like, wow, these are extremely fragile. I wonder how much pressure these can withstand, Those sort of questions would have never occurred to me had I not done these things. Oh, she was extremely supportive. Every week, besides the general group meeting where you would anyway discuss what you've been up to during the week with everybody, she would have one-on-one with us where she'd be like, okay, what did you do this week? How can you improve? What can you do next? What sort of? It's never a straight line. Yeah. Personally, I found it extremely difficult to balance my school time and research because I was working non-stop, working weekends, every single breathing minute. I was dreaming about this, and I'm not kidding. I wish I were, but I was dreaming about this, and I had to take a step back when the first wave of disappointment hit, and then our backup also failed, and the second wave of disappointment hit. And I was like, okay. Then you have to look at it in the long run. Be like, okay. These are wafers that I cleaned yesterday, and as you can see, it's still very shiny and nice, and it's by a standard cleaning solution, nothing special about this. The color change between amorphous and gamma, and this is actually a visual correction that we use because I'm really hoping, to be honest, to get quantitative results by the time we get to the conference. But at this point, I don't have that, so I kept it vague enough for that, to allow me for that freedom, but descriptive enough to let the reader know what we're doing. So I thought I was a little proud of that, to be honest.
Nice, yeah.
What we're doing in this project is growing carbon nanotubes with an alumina coating, which is biocompatible with cells, and we are delivering specific proteins and antigens to dendritic cells and HeLa cells. So the goal, in short, is to show that the nanowires are a much more highly efficient delivery mechanism than what happens in vitro. Very happy because I actually managed to grow about 70 pieces of carbon nanotubes, which is a lot of work. However, it's really important for us to have a good number of wafer pieces so that we can have repeatability in our experimentation. Well, I had initially not expected to be as involved as I thought I would be, because in any previous situation I've never had as much leeway I've never been given as much leeway in just, okay, go figure it out, or do it yourself, or this is the plan, tell me what you can do with it, or improve it. It was usually, well, you need to do A, B, C, D, and I'm extremely efficient so I can do it fast. But when somebody tells you, well, figure it out, then I happen to be one of those nitpicky persons who will just verify, double verify, triple verify whether it's correct or not. Because I don't want to make a stupid mistake and then just waste resources, especially in a research environment. Researchers are very scarce. So that was a huge surprise. I did not expect to be chosen for that, just because I had heard rumors that students who apply the first time don't get it. But I was like, okay, let me just try my best. At the very least, I'm going to learn how to write an abstract. So that's what I did, and I was very surprised to get chosen. What I expect is to see how technology changes through research, and how industry is influenced by it, because we tend to see companies like Intel or bigger companies like Samsung, who are on the forefront of their technological breakthroughs, making all these products, yet they still get involved with research at universities who have a different mindset about the whole thing. So I want to see what that intersection looks like. My advice would be, have confidence in yourself, suggest things which may sound ridiculous, but see what the reaction looks like. Just because you think it's ridiculous does not mean everybody else is going to think it's ridiculous. And ask questions. Don't be afraid of asking questions. I think that's the biggest problem people have, is asking for help and asking random questions, or thinking that they ought to know something when they're not expected to know anything. So if you don't show interest, nobody's going to be interested in you. It's very simple. If you're not going to be interested in asking questions, if you're not going to be interested in volunteering to learn more, even if it sounds really menial and tedious, you might be surprised at how much you can learn. So you have to show you have to show interest for other people to want to help you.